Hello, my name's Brian. I'm an Agile management consultant, and earlier last year I left the smoke of old London town and headed north. Welcome to glorious Yorkshire. Now I'm using the Agile management practices to get stuff done around the house. We have some grand plans on the roadmap. But plans are nothing. We've actually got to get stuff done. But if agility is just a bunch of silly words to you, then don't worry. Stick around. Just enjoy watching stuff getting done. We need to have a conversation about phase gates. For many in the Agile world, phase gates are a dirty word because they bring back bad memories of the old world, of sign off the requirements up front, sign off the design up front. And those arguably didn't really work when you're dealing with problem solving, where you need to experiment. But actually, agility utilizes phase gates, most famous of which is the definition of done. How do we know when a piece of work is done? Well, we have a checklist of all the actions, the items we should have been through to ensure that it is done and done to the right level of quality. I'm about to start on the construction of the lean-to. And before I get into the construction, I need to make sure that I've done all of the fabrication. A checklist is going to be quite useful here because once the timber is in situ, it's been put into the construction, it's going to be very hard to machine it any further. So all those machining operations need to be finished now. I know that I still have to drill peg holes for the braces. That's got to be done. The sole plates, they need to be machined, and at that end, at the bottom of the posts, the slots to take the sole plates need to be dealt with. So there's a couple of things still to go before I can start putting it all together.
Peg holes. The jig from earlier makes drilling these easy and accurate. One thing ticked off the checklist. Previously, I'd spent an age getting straight timber for the sole plates that was the right thickness.
Right. We go in there-ish. And we go in there-ish.
Now the prepared timber needs finishing.
I want that to be 12.7, so we keep that way and then come back. Okay.
It needs to be cut to length and a little rabbet carved out of the end to create a tenon that will fit into a corresponding slot in the bottom of the posts to secure the sole plate. I do have a rebate cutting set somewhere, but I can't find it. So I use the templates from machining the posts to act as a square edge and use a top bearing router bit to create the tenon. The inner face of the tenon is in the correct position to fit against the post. The tongue of the tenon needs trimming down to fit the mortise in the post.
12.6. That is perfect. Okay. So now we need to just take that edge off to get 12.7 deep. How am I going to do that? So that is currently 16. That wants to be 36. There. You've shifted. There. Right. Square, square. Okay. Ten. I don't know where my maths went wrong. I think I'm overthinking it. That distance, that has to be precise to fit into the slot. That distance has to be precise to fit into the slot. But that distance across there, as long as that is under 12.7 millimeters, not massively under, but just under, then we're good to go.
The tenon doesn't need to be the exact depth of the mortise. It could be shorter. Indeed, it should be shorter, because the cross grain of the post will shrink more than the longitudinal grain of the sole plate. A gap is needed to allow the post to shrink, otherwise it will push the sole plate out of the joint.
12-1. That's perfect. Perfect. Just need to tidy them up.
Another item checked off the list. The posts need to be cut to length. The post is thicker than the depth of the circular saw, so it takes a few passes from different sides to make the cut all the way through.
So that's the end trimmed to length and perfectly flat. One last thing to do, and that is drill the center hole for the locating pin. Following the grain, isn't it? That's the worst of the lot we've done. why there's a bit of play in all of it. It's there to stop it sliding out, not to hold it exactly in place. So in terms of the checklist, I've got to do little rebate for the door header on one of the posts, drill holes on the last beam, and that's it. We're getting there. Yeah, we get ourselves down to depth. How are we going to reposition over to there? Do I just reposition this and risk it that I can keep it? Could potentially use that. It's a one-off, we will risk it. Eyes and ears. Right, that is off, on at the socket. .7 matches everything else, doesn't it? Because that's half inch. Right. Right, I think just going to do it old school. Annoyingly, that's what I was trying to avoid, but never mind. Good. All right. So I'm thinking about the ridge beam, and I need to get the ridge beam screwed in up here. How do I hold it all level whilst I'm trying to drill holes in all the right places? I was thinking, do I have any spare timber? And then it occurred to me that actually the timber that I'm going to use to act as the studding from where the footers are running up to where the beam is going to run at about that height, that's going to be exactly the right height to fit up under here. So it's probably the plan.
I have some frame fixings somewhere. The frame fixings use an 8mm hole, and I intend to use those same holes to support the ridge beam, whilst I drill through the other holes to secure it to the wall. This means I need 8mm bolts,
Not long enough.
which isn't a size that I have a large stock of.
That'll work. Just need another one of them. That'll do. We know that the studs can't go any taller than the bottom of the soffits there, because the roof of the lean-to has to be under the soffits. So if I cut them to that length, I can use them for holding everything up and then cut them down again later in order to properly fit all of the roof line. 2075. Everything to that height.
I know where the rafters are supposed to go, so I can pre-drill the ridge beam for frame fixings on either side of where a rafter will sit. 2 of the pre-drilled holes are used by the support legs to position the ridge beam at the right height. The holes in the support legs were deliberately drilled slightly too high. Therefore, by angling the legs, I can adjust the height downwards to the exact position I want. Angling the legs has the added benefit of pushing the ridge beam towards the bricks supporting the eaves, minimizing lateral movement. With everything positioned, I can drill through the pre-drilled holes into the bricks and knock in the frame fixings. Once enough fixings are in place to support the ridge beam, then the legs can be removed and the holes that the legs were in drilled through and the frame fixings inserted. The second ridge beam has a notch formed in it to allow it to sit behind the existing drain pipe. The miter saw is set to the right depth and a couple of cuts pushed through, which makes manually chiseling out the remainder much easier. The join is clamped to keep it aligned, then the legs positioned to set the ridge beam at the right height, and finally the holes for the frame fixing are drilled. Final item on the checklist ticked off. It's too late to start actual construction, but I want to check that everything fits. Agile principle of integrate early and often. A rafter is bolted onto the ridge beam and a post is dropped into place.
There.
Everything looks like it's lining up. The distances all appear correct.
That should be it. Maybe we do just need to round that over, that edge over.
It gets dismantled overnight. Actual construction can start tomorrow. But that is for another day.